Okay, good evening, everyone. Can you hear me? Okay, can you hear me?
Yes, we can hear. Good evening.
Okay.
Yes, sir. Yes, sir.
Okay, thank you. Okay. Okay, just we're waiting 1 minute, then we'll start.
Sir, till the program is started, actually, this is RK Avasti calling, sir.
Yeah, please.
Actually, I have sent one code, sir, actually, on your ID. There was some issue, actually, sir.
Okay, so after completing the 3 hours live training, then we talk about the problem solving class also.
Okay, okay.
Okay. We also discuss about the problem solving after completing the 3 hours live training program. Okay, so we will start. So hope all are you well, and you already got all of previous recorded class. So basically, I already provide that first day and second day's recorded class in our Google Classroom. So I hope you also try to watch it again and also learn. Okay. So after completing the total 3 hours live training program, then we talk about the 1 hours for the problem solving class. Okay. In the problem solving class, you can easily share your problem regarding the previous class. Then I also try to give the solution about that. Okay. So let me share my screen. Then we'll start. So basically today is our third number of class. Let me share my screen. Okay, can you see my screen?
Yes, we can see.
Okay, thank you. So basically today I talk about that this type of topic. So mainly calculating any indices, how we can easily calculate any indices using the Landsat or Sentinel satellite imagery, and how we can easily filtering and displaying the satellite image for Sentinel-2. So previous class I discussed about that Landsat satellite imagery, how we can easily filtering and displaying this satellite imagery. So today's session I show you that how we can easily filtering and displaying the satellite image, mainly Sentinel-2, and then we monitor the NDWI or NDVI. Mainly we can easily monitor the water on the surface of the water as well as the vegetation. We also discuss about that, and how we can easily extract the water body using thresholding technique. We can easily apply the thresholding value, and then we regarding this value we can simply extract the water pixel. We also discuss about that, as well as I talk about the NDVI, NDWI, SAVI, or any other indices, how we can easily create the time series chart. Okay, mainly check the temporal analysis. In this time series chart, I also mentioned about that previous one topic, mainly annual, how we can easily create the annual or monthly time series chart. We also discuss about this in this time, as well as we discuss about the export any shape file, how we can easily export, and how to add the gradient legend on title, legend and title, how we can easily add in the Google Earth Engine platform, as well as we also discuss about the Sentinel-1 imagery to use for making the flood mapping, how we can easily detect the flood water using the Sentinel-1 SAR data, as well as we talk about the monthly time series chart, how we can easily create for NDVI, NWI, or any other indices, how we can easily create the monthly time series chart. So let's go one by one. We try to discuss, and after completing this all of topic, mainly 3 hours, then we talk about after completing these things, we talk about the problem solving for all of problem, and also talk about the solution. So let's go. And we already know about that for filtering process for Landsat imagery. this same concept we also use in here to filtering and visualizing the Sentinel 2 satellite imagery. This same approach we try to put in here, and further we just filtering the Sentinel 2 satellite imagery. Okay, so previous class I discussed about this type of factor. So basically one factor is the region of interest, mainly where you need this image. For Sentinel 2 satellite imagery, we also apply the same process. First of all, where you need this image, mainly your boundary study area or boundary shapefile. Suppose in this case, I need this image for the Dhaka city boundary. So just I simply import the Dhaka city boundary. And then you filtering your image properties. Suppose I need the image, then so I get less than 1% cloud cover image I need. Okay, so this is the another factor. And third factor is that you get for a specific time period. Suppose summer season, rainy season, or any other specific time period, or pre-flood or post-flood. Okay, so any specific time period for your depend on your research work. Simply set your time period. So basically, using this three factor, we can easily filtering our Sentinel-2 satellite imagery. For that, we can easily monitor the different types of things. So let's go in this time, we also apply the same process, also filtering the Sentinel-2 satellite image collection. So first of all, just simply click on the browse data catalog. And from this data catalog, we can easily access all of image collection for Sentinel. So just click on the Sentinel. So now it open all of Sentinel image collection. For Sentinel-1, mainly SAR data, or Sentinel-2 multispectral instrument, as well as Sentinel-3 ocean color, or Sentinel-5P trophomy. So all of those things we can easily get it from here. So in this case, I want to work for Sentinel-2, mainly multispectral instrument. And further, I want to monitor, suppose, water logging or flood monitoring. I want to use to detect the flood water or detect the water logging for rain. Any purpose, different purpose, we can use it, no problem. So I'll show you the method how we can work with that. So this is the Sentinel-2 satellite imagery, and they also give this type of notice. So basically, this type of data set is the updating all time. So we can easily get their update notice from here also. Okay, as well as you can see about that data set. Basically, find out that surface reflectance and also top of atmosphere reflectance. So both our images are very important for different purpose. So basically, this surface reflectance is very useful to work for the land use land cover mapping, as well as also for you can also do for that flood mapping. Okay, we can easily use it to get the more better result. Okay, and top of atmosphere reflectance, mainly useful for creating the different types of indices such as NDVI, NDWI, or any other indices. You can also use it. And both our images are the same process. When you filtering the surface reflectance or top of atmosphere, just apply the same process which I show you. So surface, I suppose I show you for the surface reflectance. Just click on here. So now we got all of surface reflectance satellite image for Sentinel-2 information. So first information is the dataset availability. So this dataset is available from 2017 to 2024 0926. Okay, and now is the 27. Okay, so it's the update data, so we can easily get it from here. And this dataset provided is the European Union ES Copernicus, and same as this is the unique ID about this dataset. Okay, and we got all of information from here for this dataset. Here you can see we can got all of band B1, B2, B3. Okay, mainly coastal aerosol, then blue band, then green band. Okay, then red band, then red is one band, red is two band. So all of band we can easily get from here. As well as you can see about the scale. Okay, this type of band also have this type of scale. And here you can see the some band is the 60 meter, some band is the 10 meter, some bands are the 20 miles. Okay, so now I want to use it, and further I want to filtering for the different season. Okay, suppose I want to filter this image collection for rainy season and summer season, and then further I want to calculate the NWI, and then I want to check for the rainy season how much water body increase. Okay, then dry season, and also calculate the water body area. So let's go. I try to explain one by one all of method. So first of all, this image collection I need to import in my code editor. Okay, so just copy this snippet ID or unique ID, copy, and then paste here. Okay, just I simply paste here this unique ID. Then now this image collection I need to import store it in a variable name. So you already know about that, how we can easily create the variable name in JavaScript programming. So same as just take the var keyword and put the variable name. Variable name can be anything. Suppose I put the name is that Sentinel 2. Okay, you can put any name as a variable. So now what happened? So now this image collection is stored in this variable. Okay, so now this image collection is stored in this variable. This variable name is the Sentinel 2. So now this image collection, I want to filter for 2 time period. Suppose dry season and rainy season. So for that, suppose first of all I filtered the image for dry season. So just take a variable. I put the variable name, suppose dry image, or you can put any name as a variable. So this variable Sentinel2, it stored this image collection. Okay, just simply copy and paste here. Further, this image collection I simply filter, and this image collection is stored in this variable. So just I call this variable name, and now I want to filter. So first of all, where you need this image, mainly your study area, you need to filtering your study area. For filtering the study area, I simply use here the filter bounds function. You mainly filter bounds function. This argument is the geometry, mainly your polygon, which area you want to need the imagery. So then suppose I need the image for my study area, suppose Dhaka city. So just simply import your Dhaka city boundary. Okay, so here I already imported the Dhaka city boundary in my asset tab. So further from here, I just simply import the asset tab in here. Okay, so let me find out this shapefile. Okay, so this is my shapefile. Here I already uploaded my shapefile in the asset tab. So now I just simply click on the import tab and then import this boundary shapefile. So just simply import. So now my boundary is the imported and default variable name as is table. Okay. So just I simply change it. Suppose I put the name is that RY. You can put any name as a variable. So now this Sentinel-2 image I need for my study area of Dhaka city, and Dhaka city boundary is stored in the ROI. So just put here ROI. Okay. So this is the one factor. It's called that where, mainly where you need this image. Okay. After completing these things, we talk about the second factor. Suppose I need the image less than 1% cloud cover. Okay, I need the image less than 1% cloud cover. So we already know about that. For this, we have to use the function filter metadata. Okay, we have to use this function for filtering the image properties. And in this time, what is the image properties name? Then set the operator and set the value. Okay, so you can easily get the properties name from here, from your data catalog page. Here you can see the image properties. I choose suppose cloud pixel percentage. Then paste here. Just simply paste here. Okay. Then set the operator. So I set the operator suppose less than, and then 1. So now what happened? So now all of less than 1% cloud covered image for my study area, it is stored in this variable. Okay, in this dry image, it is stored in this variable. All of image less than 1% cloud cover for my study area. Okay. And finally, we also need the another, mainly a specific time period. Suppose I need this image for the dry season. So just I put the dry season time period. Or I need the image for the wet season, or I need the image for the month of January or month of February or January to February or January to March. So any time period we simply set in here. So let's guys simply put this time, suppose filter date for a specific time period, mainly start date and end date. Suppose year of 2000, suppose 20, 1st January from year of 2020, suppose 05, suppose 30. Okay, I consider this is the dry season period in Bangladesh. Okay, or you can put any time period for your own study area. Okay, so now further, if I check how much image is available, so just simply use the print function and call the dry image, and then just use the size function, mainly size function computing how much images are available. in this variable. So we find out that 15 images. Okay, we find out that 15 images are available in this variable. Okay, so in this case, if you want to use all of images and create the median composite, we already know about the median. So basically, median composite, take the middle pixel value and create the composite. We already know. So suppose I just simply put here that dot median. Now what happened? After applying the median function, all of 15 images, take the middle pixel value and create the one composite. Okay, when I apply the median. Okay, and if now I just click to the run, you can see we can get a problem. It show the size is not a function. Okay, size is not a function because after applying the median, this variable just stored a image, not image collection. Size function is only work for the collection. Okay, this function is only work for the collection. But when I apply the median function, then this variable is a image, single median composite image, not a collection. That's why when I use the size function and I want to compute, then it show the size is not a function because size is only work for a collection, not a single image. So just I simply remove, suppose just I simply remove the median, then you can see what happened. Just I remove it and click to the run. So now it will work. There is no problem because now this variable stored the total 15 images. 15 images mainly one collection. 15 image collection. But when I compute the median, just put here the median, then this variable stored a single image. Click to the run, you can see what happened. It show the size is not a function because size is only work for a collection. Okay, so just I put the median, then this variable is not a collection, it's just a single median composite image. Okay, and then we can easily apply the clip function. Okay, because clip function is only work for image, not collection. Without median, if I use the clip function, then it also not work because clip function is only work for the image. So just I simply create the image, median composite image, and further I clip with my study area. So in this case, my study area is the Dhaka city boundary. I put here ROI. Okay. So now it's okay. So now I just try to add my layer. So just put here map dot add layer and call the dry image. Click to the run and also run. So now it's added the layer, but it not focus. So further focusing, we already know about that. For center focus on the given study area, we have to use the function map dot center object. Object mainly study area ROI, and put the suppose zoom level. I put here the zoom level suppose 10. Click to run. So now it directly focus on my study area. We got this type of image here. Okay, but it shows as a black color because it shows the default visualization. Okay, so now further we can simply add the visualization. Suppose just click on the properties, layer properties button, and I set it suppose red, then put here that green, and also put here the blue, and custom stressing suppose 98%, or any band combination you can use easily from here. And now further apply. Okay, so now we got this type of imagery. So you can see we got this type of imagery. We get the natural color. Okay, and this imagery is more better than just a minute, I face a problem. I think some networking issue. I think some networking issue. Sorry for that. Okay. Okay, let me open the new code editor and then run the code again. Just a minute. So that's why it also better when you write the code. Always you try to save it. Okay, then it not rewrite again. Okay, so I don't save it. So that's why in this time this you can see it, this site this page is the crash for the networking issue. It's not loaded. Okay, so let me write the code again. So I write the code first. Just a minute. So that's why when you want to write the code, try to save it. Okay, and then it also save, so not destroy further. Okay, so now it's work. I think some networking issue. That's why it takes some time. Okay, so let me write the code again. Okay, so now we try to display this imagery. Just move to that layer and call this dry image. So now I'll put here map dot center object for focusing on study area. Okay. So now just run the code. Okay, so further we try to add the visualization from here. Just click on here and I set it, suppose 4 red, then green and blue. Stressing 98%. And here you can see we get this type of value. You can see 677.54, 1807. Okay, so this value is not represented. Okay, in this case, if you want to check the bands, then you also get this type of scale value. You can say scale. So all of bands are the same scale. Here you can see. Okay, all of bands have the same scale value. So for that, I simply copy this scale value, and I want to multiply this scale value with my image. So just I put here the dot multiply and then paste this value. So now this is scale value is multiplied with my median composite image, and then we get a proper pixel value. So now further, just click on here and then put here, suppose before red, then green and blue. So custom stressing 98% and apply. So further here you can see we got this type of result. So it show this type of result. Got it year of 2020 dry season imagery, look like that. Okay. And further, just simply if you want, you can also import the visualization parameter. So this is our satellite imagery for the dry season. Okay, so in this case we are using the filter metadata function. Okay, so basically filter metadata function we are used for filtering the image metadata, but instead of the filter metadata function we can also use the another function. It's called the short function. I also explain about the short function. Suppose I want to use the short function, short. Okay, so short function is also useful for filtering the image properties or image metadata, and I want to short using this cloud pixel percentage. Okay, so now if I run the code, you can see what happened. Just I use the short function. I don't put any kinds of value, mainly less than 1%, 2%. I don't put. And now if I run the code and save the visualization, and suppose I put at that before red, green, and blue, tracing 98%, and further apply. So now we got this type of cloudy pixel. Here you can see it show this type of cloudy pixel. Okay. It show this type of cloudy pixel. And it show the less cloud because I use at the median composite. Okay, so in this case you can see I just use the median composite. So basically median composite also help to remove the cloud. Okay, and also put the better image collection. But if I use the another composite instead of the median, suppose I just take the mosaic, just use at the mosaic. So mosaic is another reducer in Google Earth Engine. So in this case, we are not calculating the any kinds of mean pixel value or median pixel value. We are just use the mosaic. It means that all of images between this time period 2020 January to May, all of images we consider and extract with our this study area. So now if I run the code, you can see what happened. So in this case, we find out the lot of cloud. If I run the code, suppose before red, then green, and blue. So it's testing 98% and apply. So you can see that the all of cloud is available. Okay, so there is a totally cloudy image. Okay, so now this type of cloud I want to remove and then get the very neat and clean satellite imagery. So for that we have to use the one Boolean operator in here. Just put here the false. Okay, so when I apply the false, then all of cloudy pixel from this imagery will be removed, and then we can get the very neat and clean satellite imagery. So now run the code again and then check what happened after applying the false Boolean operator. And now run the code. Just put here the red, then green, and blue. Stressing suppose 98%. Apply. So now we got the neat and clean satellite imagery. And so you can get the very neat and clean satellite imagery. There is no cloud. But if I remove the false operator and use the mosaic composite, then we find out that lot of cloud. Okay. So basically this short function you use when you want to not put any kind of specific cloud level. Suppose sometime you need the less than 1%, 2%, or 5%, 10%. Okay. Then we can easily use the filter metadata function. With filter metadata function, we select the range. Suppose I need the less than 5%, less than 10% or 15%. But in the short function, we are sorting according to the cloud pixel percentage and use the false operator. So basically this false operator remove all of cloudy pixel between this time period. So now what's the benefit? Suppose when I use the filter metadata function, then how much image I got. So if you want to check it, suppose just I simply commenting all of line, and then I check how much image I got when I apply the short function. Just I commenting, just use here the print and call it your try image. Copy that, and I just apply the size function. Then it computed how much image is available. So here again, so you find out that 60 images. Okay, so it increased my image collection when I apply the short function. Okay, so it increased my image collection, and when I use the filter metadata function and choose the less than 1%, then you can see how much image you can get, 15 images. So what is the benefit to use the short function? In this time, we find out that it increased our image collection, and when it increased the image collection, then we can easily make the more better temporal analysis. Suppose when you want to make the time series chart, you have total 60 images. So that's why you can easily interpolate the total 60 values. We can easily get it. So in this case, I have only for the 15 images. So I got only for the 15 values in my time series chart. So that's the benefit. You just increase the image collection. Then we can simply use the short function. And then we find out that it shows the total 60 images. Okay. But this 60 images is also considered some cloudy pixel. But when I apply the false function, then all of cloudy pixel will be removed. Then we can get the very neat and clean satellite imagery. And I can easily apply the mosaic function. Mainly all of 60 images create this mosaic using the max function. It creates the mosaic, not calculate any kinds of mean, median, or max values. So now just we try to edit and display this map. And okay, so we got this type of imagery. So now we can see I just set the color or band combination. Suppose just put here that B4, B3, and B2, red, green, and blue. Just stressing 98%, and further just apply. Okay. So now it added the natural color. We can easily find out this type of satellite imagery. And this visualization parameter, we can easily import. Suppose just I simply click on the import function and then copy this variable name. And this visualization parameter I want to set with my map. Just after the layer name, just put this variable name. Okay. And then give a variable name. In this time, it show about that layer 1. Okay. But I want to show a display layer name. I put this, it's a dry image. Okay, we can put any name as a layer. So now it's ready for the dry season image. We can easily get it from here. Okay, so now any question you can ask me about this code. Any question regarding this code you can ask me. Or any confusion for any function.
Hello, sir.
Yeah, please.
Yeah, so I want to ask about you said about the like a cloud cover. You remove the cloud cover, right, from 2020-01 to 2025-30 in a dry season, dry image. You remove the cloud cover, but let's say, like for example, if I'm doing let's say related to the crop, agriculture crop growth, time series analysis,
Yeah.
and then which month or which day like the has like the cloud and which day has no cloud. Can we check that also?
Okay, so basically when you want to make the time series chart, then we need to the more image collection. Then we can easily find out that more values, okay, for different time. So in this case, if I just use the short function and apply the false, then we find it increase our image collection. Okay, and further when I use this image collection to create the time series chart for any time series chart, it can be NDWI or NDVI or any other time series chart for any indices, then we also get the more better time series chart. Okay, because in this case my image collection is also increased. Okay, but when I put the less than 1%, it should only for the 15 images. Suppose if I put the 2, then it also increase, or 5 less than 5% also increase. But when I apply the short function, then it also increase. Okay, this is another way for filtering the image collection. Right? Yeah, any question, please? Okay.
Excuse me, just a second parameter in the map add layer, the image
Yeah.
the image yeah, the second one. Yes, what's the parameter?
Okay, so basically we are just adding the visualization. Okay, so you can see here when I just click on here and then we set the visualization, suppose before red, green and blue band. Okay, and then stressing, then we can apply, then this visualization will be add in my map. But this visualization parameter I need to add in my map. Okay, so further when I run the code, it will be not removed. So for that I simply click on the import button, then this line added in my code editor. Okay, so further I simply copy and set after the layer name. Okay, so in this time my map.add layer, this is my dry image. After that I simply put it this variable name. Okay, and then put the layer name. Okay, so now you can see it show also the layer name in here, and this it's come from this visualization parameter. Okay, when I just click on the import, then it added the new variable in here. So simply copy this variable name and paste after the dry image. Okay. Yeah, any question? Okay, so basically you have to import your own study area. Okay, so basically if you have this shapefile of Dhaka city boundary, then you can easily work with that. Yes, about this file.
Sir, I have one question, sir.
Yeah, please.
Sir, actually, sir, the imagery basically which are available cloud free already, like Modis and all that. I think there is no need of this removal of clouds, na, sir?
Also, actually, in this time, this imagery is also including the cloud, all of cloud. It's not the, it's just do for the atmospheric correction. Okay, in Google Earth Engine platform, basically this type of atmospheric correction is already done. So that's why in this time we are not doing that any kinds of atmospheric correction or enhancement. Okay, and then you can simply, it also have the cloud. So this type of cloud we can easily filtering using the filter metadata or short function we use, and further remove the cloud. But Modis product is totally remove all of cloud, such as Modis NDVI or Modis other product is already remove all of cloud.
Okay, sir.
Okay. 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 So any question? Okay, let me share the code link with you. Then you can easily access my boundary shapefile easily and also continue the work. And further, when you want to work for your own study area, simply import your shapefile and then you can easily work with that. Okay, so now if you want, simply go to this link, then you can easily access the full code which I write in here. Yeah. Okay. So this is the process. In this time, the same process, I can also apply the another time period. Suppose I want to apply it for rainy season or wet season. Okay. So for that, what we can do? just simply copy the same, code. Okay, we are not change later. Just simply copy and paste here. Okay, then just I simply change the variable name. Suppose I put the variable name is that, simply put the variable name, suppose wait season or rain wait image. Okay, and then same process. I just simply take here, suppose 06 from October 30. Okay, and same, just simply copy and paste here. Okay, and then okay, I add the later. I want to add it later. Okay. Okay, I will show you this, no problems, because we have also another 1 hours for the problem solving. Okay, in the problem solving, I also show you this process. I put it, suppose wait image. Okay. So now if I run the code, so now we can easily get the wait season imagery, another layer. It shows another layer for wait season imagery. Okay. So now further, if I just run in here and then set it, suppose band 4, band 3, and band 2. Okay, red, green, and blue, stressing 98%, and further just apply. And then you can see this, it added the visualization, look like that. And when I click on the import, you can see again, so when I click on the import, a new line of code will be added. Okay, just simply copy, and this variable I paste after the layer name. Okay, so just paste here. So now this value will be set. So now you got the 2 time period satellite imagery. One is the rainy season, another is the wet season. So here you can see, for the rainy season, we find out this type of cloudy image. In the we did not get the more bright image. So it showed this type of, you can see this, the darkness image we find out in the rainy season. Okay, but it also have another process to get the more better visualization. So tomorrow, inshallah, I talk about that, how we can easily remove the cloud. You can see it also is still some cloud. We got this type of cloud. Okay, but this type of cloud and also this type of cloud shadow. So basically, normally we find out that rainy season, a lot of cloud in the sky. Okay, so that's why it shows this type of cloud. But in Google Earth Engine platform, we can easily remove this type of cloud. So these things I also explain in the further next class, inshallah, and talk about the all of things. So now here I got this type of 2 imagery. So here you can see one is the dry image. Dry image is very neat and clean. Okay, so for that, for this region, lot of researchers, when they are need the satellite images, they try to focus on the dry season. Okay, for that, because in the dry season we can easily find out very neat and clean satellite imagery for any purpose, for any analysis. So that's why a lot of researchers they try to filter their image collection in the dry season, because dry season we can easily get the very neat and clean satellite imagery, and we can easily do for this analysis. So now we got this type of imagery in the wet season and dry season. So my main target is that I want to make the NDWI map, okay, for this 2 time period, and further I want to observe what is the condition on the water surface in the rainy season, how much water body increase in the rainy season. So this process is also applicable when you want to do for the flood mapping. Suppose you take the imagery for the before flood and also take the image for the after flood. Okay, and further you create this type of 2 imagery. One image display the result for before flood, another image display the result for after flood. Okay, you take this composite for before flood and after flood, and further just calculate any water index. It can be NDWI or MNDWI or any other water index. Simply apply, and further you try to extract the water body pixel using the thresholding value. Okay, so let's go. We try to discuss about that, how we can easily create the water body index. So basically, there are a lot of water body indexes available. If I simply search on the Google, suppose water index in remote sensing, I simply search. Okay, so just simply open it. So from here you can easily get the different types of water index and their application. Okay, I also send this type of material link in our Google Classroom. You can easily read it further to get the more knowledge. So here you can see we can easily get it this type of water index as monitoring tool for water body. One is that NDWI. So basically the normalized difference water index. Okay, and this is the formula. Here you can see near infrared minus short infrared 2, near infrared plus short infrared 2. Okay, this is the one kind of formula for monitoring the NDWI, and you can see there are a lot of uses monitoring the changes in the water content in leaves, or analysis of the susceptibility of the study area of fires, modeling plant fertility, detection of the surface water in spam areas, measuring the extent of the coverage surface water. So further you also read all of things one by one. Also you can see about that the map look like. You can see also the another one. So this is the WRI, mainly water ratio index. So this is the formula about that water ratio index, as well as also you can see about that the use about that. You can get the modified, mainly MNDWI. Okay, so MNDWI. Okay, so here you can see the formula. Okay, and this is the uses about that. Okay, so you also read about it, you can easily get it, no problem. So now from here, suppose I want to calculate the MNDWI. Okay, so basically this formula is the green minus shortwave infrared 2 divided by green plus shortwave infrared 2. So this formula I want to apply, and then further I want to calculate the MNDWI. Okay, not only for this index, I also try to explain any kinds of index, any kinds of equation. In remote sensing, we find out the lot of equation, lot of index, different types of formula. So I hope after completing this class, you are able to calculate any kinds of formula using Google Earth Engine and also make the analysis. So let's go. We try to calculate this formula and then check what is the scenario of the MNDWI. MNDWI basically modified normalized difference water index. Okay, so basically you can see it used to detect the water bodies in satellite imagery. Okay, so we can easily detect the water body using this formula. So let's go. We try to implement it in our satellite Google Earth Engine and check what we can got. So basically this is our formula. Okay, so now this formula I want to calculate. So there's a lot of way to calculate this type of formula. So I will show you all of way step by step. So one way is the very easiest way. It's called the normalized difference function. If I simply search on the docs tab, suppose I simply search normalized difference. So this is the function. So this is the function mainly we can use to compute the normalized difference between two band. So when you want to calculate the normalized difference between two band, then we can easily use it. And here you can see the band name. We are just mentioned here the band name. Suppose which band I want to calculate. I just put the band name. And the normalized difference is computed as first band minus second band divided by first band plus second band. So in this case, for my formula, we got this type of formula: green and short wave infrared 2 band. So green and short wave infrared 2 band. So there is the 2 band. Okay. So now I can easily use this function, normalized difference function, and calculate the NDWI or MNDWI. Okay. So it computed first band minus second band divided by first band plus second band. Okay. So let's go try to use it. So for that, just take a variable. Suppose I want to calculate the MNDWI for that your suppose dry season. Suppose I put the variable dry, put the dry NDWI, NDWI. Okay, and then equal sign. Now call the dry season image. I already make the dry season image. Here you can see this is my dry season image. I already make. And this dry season image is already stored in a variable. What's the variable name? This is the dry image. Just simply copy and then paste here. Okay. So now just apply this function, normalized difference. So this is the function I need to apply, normalized difference. And then I need to mention the band name, band name. So in this case, my band is the green band and shortwave infrared band. So just I put here the green band, suppose green band is that B3 and shortwave infrared band is that B11. Okay. So just I put here the, sorry, B12. You can easily get it from the band name here. You can see. We can easily get it for that band. Shortwave infrared 1 is the B11. Shortwave infrared 2 basically it is the B12. You can see, you can get it B3. B3 is the green band. Okay. So put here the B3 and we just put in here. So now it calculates the NWI map. If I run the code map.add layer and then just copy this variable name. Okay, so in this case we got a problem. What is the problem? This problem is that here you can see it have more than one, mainly B3 and B12. There are the two band. Okay, so for that we have to create the list, and for the creating the list we have to use the square bracket. Okay, because it's a list, two item in my list, two band name B3 and B12. So now it will be worked. It creates another layer. So you can see it loaded. We got this type of map. Okay. So now try to add the visualization. Just click on here. And further stressing, suppose 98% I put. And further just try to add the color. Suppose I want to show this type of color. Where there is no water, it shows as a red color. There is no water body. Then increasing, basically what happened? Basically positive value. Okay, positive value indicating the water pixel. And negative value indicating there is no water. So I consider it that there is no water, negative pixel, show as a red color. Greater than, I want to show this type of yellow color. Then greater than show this type of suppose green color. And greater than put here the water body as a blue color. Okay. So now further apply. So now we got this type of map. Here you can see we got this type of map. So just click on the import button. When I click on the import button, it added the new line of code. Copy that and paste after the object name. Just paste here and put the layer name. I put the layer name, suppose NDWI dry. So now it loaded. So now the same things, I also need to create this water body map for rainy season. Okay, so we got this map for the dry season. So now I also need this map for rainy season or wet season. Just copy the same code. Simply copy. And then paste here. And then in this case, I need the wet season image. I also change the name. Suppose it's a wet NWI, and I call the wet season satellite imagery. I already create the wet season imagery. Okay, and this imagery is stored in a variable. This variable name is the wet image. Okay, so this variable is stored the wet season imagery. So just I paste here. Okay. And then I want to display it. Simply copy and paste here. I add the letter. Just I put the blank or empty and further click to the run. So now it added the new NWI map for rainy season. I also changed the layer name. It's NWI for wet. Okay. And now it also loaded here. You can see further you can easily add the color. So just click on here again. And then I just put the simply stressing 98%. And now just click on the plated. and I show there is no water body, show as a red color, where there is no greater than yellow color, greater than suppose green color, and greater than blue color. Okay, it's indicating the water body. And further apply and also import. So then further copy this variable name. When I click the import, it added the new line of code. Just copy and paste after the object name. So just paste here. Paste here. So click the run. So now we got this two map, basically two NDWI map for the wet season and rainy season. Okay, so we got this type of scenario, basically this type of blue color indicating about the water body, and this is the map of water body in the rainy season. Okay, rainy season, and this is the map for dry season. So here you can see what is the difference between the rainy season and dry season. Okay, in the rainy season or wet season, we find out the lot of water body increase. We find out the this type of place. Here you can see this type of place increase the water body. But in the dry season, you can see this dry season, we can get only for this is the water body, this is the water body. But in rainy season, you find out this type of water body. Okay, so this is the two map for rainy season and also dry season. These same things you can also apply using the flood mapping, okay, or flood water detection. You can also do it. Okay, suppose I just find out for just create this satellite imagery, just create this satellite imagery for the before flood condition. Suppose this is the image for the before flood condition, and this is the imagery for after flood condition. Further, just simply apply the NWI, then we can easily get this type of water body is the dry season water body, and we also get about that in the this is the wet season or flood, after flood we can get this type of imagery. So this is the process we can easily apply, and further we can also apply the flood monitoring. Okay, so no problem. I also send you all of code. You also try to do your own study area. Then I hope you can easily get it for your own study area also. This is the one method to detect the water body for different time period. Okay, so in this case, we try to find out the water body for the rainy season and dry season for the Dhaka city boundary. So basically, we find out that for the rainy season, this type of place also increase the water body. But dry season, you can see there was no water body. Okay, but rainy season, we find out that water body. So now I want to calculate how much water body increased, how much area water body increased in the rainy season. I want to calculate the rainy season water body area. Okay, suppose you can see this type of place, there was no water body. Also this type of place, there was no water body in the dry season. But when I just open the rainy season map, we find out this is the water body. We also get the water body. So now how much area increased the water body, we find out in the rainy season. Okay, so for that it also called the thresholding technique. We are just applying the thresholding technique, and further we can easily detect it for water body. Yeah, please, anyone, any question regarding that?
Sir, I have a question about that. Hello, sir, I'm audible.
Yeah, I can hear you, please.
Okay, sir, I have a question. We visualize there are two types, dry season and rainy season, and how can we, sir, add legend here to perfectly visualize?
Okay, so basically this type of map, when you perfectly visualize, so for that we have to export. So I'll show you that how we can easily export. Suppose here you can say I already create this type of map. So basically it's neat when you want to work submit for your research paper or your presentation, then we have to create this type of map. Suppose this is the one kind map for nitrogen dioxide density map. Also you can see this is the land use land cover map. Okay, so when you perfectly visualize this type of map, we are just download the GeoTIFF file format, and further we are just use the ArcMap software, mainly ArcGIS software or QGIS software to visualize this type of map. Okay, so I will show you this process in the 5th number class. I also show you that how we can easily create this type of map after downloading the GeoTIFF file format. Okay, after downloading the GeoTIFF file format, then we can easily create this type of map using ArcMap software or QGIS software. Okay, then you can easily use this type of map for your research paper or your presentation. Then you can easily do it. But in this case, in Google Earth Engine platform, it's also possible to visualize as a dynamic. Suppose I want to just make a dynamic website, mainly web GIS. Suppose these things I just create the link, so when anyone click on this link, they can easily get this type of map. Okay, but research paper we are not apply this type of approach. We are just creating the map using that map basic element, suppose legend, title, or map scale, or not line arrow. So all of basic elements of map we can easily add after downloading this imagery. Okay, suppose we are simply download this layer, all of imagery, dry season image or NWI map for dry season, wet season. So this type of layer we can easily download as a GeoTIFF file format. And further we are just applying the ArcMap software or QGIS software to process the final map for our research paper or scientific paper. So I will show you this process also. Then I hope we can easily get to create any kinds of map. We can easily create, no problem. Okay, so anyone in question, please.
So is there any options in Art Engine to add legend?
Yeah, it also possible. Yeah. I will show you this process, no problem. Suppose this map, we can easily add the legend in here, also add the title top of the map. It also possible. So I will show you this process also, no problem. Today's session, I also try to complete it, no problem. Okay.
Thank you.
Right. So now we got this type of map. Now I want to calculate the water body area. So for that, what is the how I can find out the thresholding value? So in this, it's very important. So for that, we have just simply checked some permanent water body. Okay. Suppose here you can see this is the one kind of lake. It's a permanent water body. It's this water body is present for that dry season as well as also rainy season. Both of time we find out the water body in here. So if I check the code here, you can see this is the water body. We find out the water body in the dry season as well as also wet season. Also there is water body. Okay, so you find out the one place where you find out the permanent water body. Okay, and further simply check the value. Just click on the inspector tab. Here you can see, just click on the inspector tab and click on here. Just click on here. So now we can easily get it for the pixel value of NWI for dry season and wet season. So we find out here, you can see 0.5 and 0.7. Okay, so dry season we find out the 0.5. Okay, and wet season we find out the 0.7. So if I check other, suppose just click on here. Okay, so 1 or 2 times simply check, and further we simply take the decision, and then we can just simply extract the rainy season water. Okay, rainy season water, not including the permanent water body. So this water is suppose 0. You can see find out the 0.5 and also 0.7. Okay, as well as if I check other place, suppose just click on here. In this case, we find out, you can see here, we find out that negative. Okay, so negative means that for this place, for this coordinate, you can see for this coordinate, latitude, longitude, for this coordinate in the dry season, there was no water body because it shows the negative pixel. Okay, it means that negative pixel indicating there is no water body. But in the rainy season, we find out the very, very high water body, 0.8. You can also check the visualization of your map. You can see, okay, it increased the water body area. It increased the water body area. Okay, suppose let me check from here. Just I click on here because this place have the water body in the rainy season and dry season both of time. So we find out the 0.5, okay, and 0.7. Okay, so from here we can take the decision. Suppose we use the 0.5 as a thresholding value. Suppose, okay, so we consider the wet season water or rainy season water greater than 0.5. Okay, all of greater than 0.5 dry season water or rainy season water we consider as a rainy pixel water. Okay, and also less than 0.5. So suppose let me we set the thresholding value for 0.5 and then calculate the area. So for that, how I can apply it? So for applying these things, we are just take a variable, put a variable. Suppose I put the variable name is that wait. Suppose wait season water area. Okay, I put this type of variable, and then I call the wait NWI. Wait NWI greater than consider 0.5 and dry NWI less than 0.5. Okay, so in this case I consider the wet season or rainy season water body area where I find out the greater than 0.5 from rainy season NWI and where you find out that dry season NWI less than 0.5. So this thresholding technique where I find out it considered as the rainy season water. So let's go try to visualize the map and then check what happened. So for doing this thing, just I take a variable, suppose map dot add layer, and I want to visualize after applying this condition. Okay, and I want to create the binary class, suppose 0 and 1 binary class, and then just put the plated where there is no water body, basically where there is not maintain this thresholding value, it shows as a suppose gray color, and where it maintains this thresholding value, it shows as a blue color. So then we try to run the code. So now it shows about this only for this blue color where we find out that rainy season water body. Okay, and gray color it shows that there is no water body, mainly it's not maintain this thresholding value, it not maintains. So we find out that this type of map. So here you can see, okay, so here you can see we find out this type of map which maintains our thresholding equation greater than 0.5 from rainy season water and less than 0.5 from dry season water. So we find out this type of map. So you can see we got this type of map. Okay, so basically this type of water pixel it increase, okay, in the rainy season. Okay, and this type of water body pixel is not available in the dry season. Okay, is not available, this type of water body is not available in the dry season. If you check the value any water body pixel, then we can easily get it. Suppose just I click on this water body. Okay, just I click on here. So now you check the value, we got this type of value, look like that. So 0.8, okay, which is greater than from 0.5. You can see for the NDWI wet season show the 0.8, okay, and it maintain our thresholding value. We find out that greater than 0.5. We said that greater than 0.5, but for my case, for my water pixel, I find out the 0.8 as well as less than 0.5. It shows the less than negative 0.002, which is less than from dry NWI or less than from 0.5. So all of water pixel. So in this case, all of blue color pixel maintain this equation. Okay, follow this equation. So NWI greater than 0.5 from rainy season water and NWI less than 0.5 from dry season water. And then we can easily got this type of map. So we can say it, this is the rainy season water body. We find out that. Okay. As well as when you apply it for your flood monitoring or flood water body map, then you can say it's the flood water. We can find out this type of things. It's a flood water. Okay. But just simply take this imagery for the before flood image composite and after flood image composite, then calculate the NWI or MNWI. Okay, just calculate the water index and further just put the thresholding value for your own study area, and then we can easily find out this type of things. For the accuracy, this type of map further we'll also discuss. Okay, but this is the basic things about applying the thresholding. But further we can also discuss about the accuracy, how we can easily calculate the accuracy. What is the accuracy about this map? We'll also discuss further later. Okay, so now anyone in question, you can ask me about the thresholding technique or any confusion. Further, we also calculate the area. Suppose how much total area in the water body, you can also calculate. So now anyone in question about this full code, you can ask me. Yeah, please. Yeah, please. Any question, please? Cannot hear you. Kindly unmuted, and then ask me.
Sir, this technique is only for only for wet season.
No, this technique can also apply for the any other season. Okay, not only for that. Or you can just take the time period. Suppose for the flood condition, we are just take the before flood composite and after flood composite, and then we can apply it. Okay, so let me show you the one example. Okay, before that, I also take the another question, please. Oliver, please.
Thank you, sir.
Yeah.
I just wonder, like, in this NDVI difference value, band 3 and band 12 are compared. But band 3 has a 10-meter resolution, band 12 has a 20-meter resolution.
Yes.
So how do they compare in this regard? Could you please clarify that, sir? Thank you.
Okay, I understand. Yeah. So now in this time, your question is that band 3 is that 10 meter and band 12 is the 20 meter pixel size. But when I computed the normalized difference using the two band, then what the pixel? Suppose in this case, I just try to make this type of map for the NWI for the wet season, or also calculate them by dry season. But this two map is generated from B3 and B12, green and shortwave unified two band. But they're the different scale. But in this case, when I just use this type of things in the Google Earth engine, then it computed this type of result is the 10 meter. Okay, because it the set with the 10 meter, because it takes the lowest cloud cover. And when I export, suppose this map I want to export. Okay, when I export, suppose just I put here the export image to drive. In this time, I also mention the scale. So here you can see it value, another value is the scale. Okay, suppose when I put here the 10 meter, then this pixel computed as a 10 meter and export. And when I put the 20 meter, then pixel computed as a 20 meter and export. Okay, so we can easily define it from here. But normally now this map shows as a 10 meter pixel area and create this type of map. And further, we also set it from here. Yeah, please. Any question, please?
Thank you, sir, for clarification. One more thing that I have come. And is there any way for us to look at the accuracy of what we were doing in here?
Yes. For the accuracy, we have to apply the machine learning model. Okay, so I will show you this type of process for this. I think it also covered in the 6th number of class. Then we can easily get it. For the accuracy, mainly we just, okay, so when I talk about the machine learning, then you can easily get it. So I also explain further. Suppose you can simply take the pixel. Okay, suppose in this time we are just create this suppose water. Suppose this type of things as a flood water. Suppose this type of thing is the flood water. This is thing is the flood water. So we can take the training sample for flood water and permanent water, and further we apply the machine learning, and then we can check the accuracy and make the classification. So this is the one kind of classification problem. When you check the accuracy, then we have to go to the classification. So then I hope you can easily get this idea how we can easily make the classification and also check the accuracy. So further class, inshallah, we talk about that. Then you can easily get this idea how it will work. But in this case, it just show the visualization. Just we are applying the thresholding value and check the visualization. But it also possible to check the accuracy. Then we have to apply the machine learning model, and then we also check the accuracy about that. Any map, any classification map, we can easily do it. But in this time, we are not making the classification. We are just take the thresholding value. Okay. So now it show about that all of water pixel greater than 0.5 from dry season NWI and less than 0.5 from dry season NWI. Now it show this type of map. And basically this map is generated from two maps which I created from NWI dry and NWI wet. Then we create this type of map from here. Okay, so it also possible. There's a lot of way to check the accuracy. We have to just apply the machine learning model, and then you can easily check it. So I'll also explain it further class. Yeah, please.
Thank you so much, sir. One more question that I'm thinking it's the capturing the images from the ground toward the satellite. The thing is that is there any effect of like a daytime and nighttime? Detecting the water bodies on ground.
Okay, it's a daytime. Okay, basically satellite imagery. So it's a mainly we have to use the passive sensor sun. So that's why this type of Landsat, Sentinel, this type of imagery detect the water body in the daytime. Okay, because this type of satellite imagery totally related with the sun for that. Okay, sun reflectance. This type of things create from the sun reflectance. Yeah, please.
So, sir, so does this NDWI consider only like a visualize a water available area, or does it also consider like the depth of water level in this regard?
Okay, so it show the area. So basically, this type of NWI it detect the water surface area. Okay, for the depth, we have to use the another way. Suppose you want to check about the what's the water body depth. So for that, we have to use the another method or another satellite imagery. But for this time, it show about only for the area of water body, surface area of the water body.
Just the extent of the water body. Thank you, sir.
Yes. But it also possible to find out the depth of the water body. It also possible to use the remote sensing technique and also calculate the depth of the water body. Okay, so now we got this type of map, and so now it show this type of. Suppose you are just simply remove the gray color. So in this time, I create the binary class. So that's why it show the 0 and 1 binary class. But I want to keep only for the one class. Okay, suppose this type of gray color I don't need. So for that, what I can do for removing the binary class, just use here the self function, self max function. This self mask function basically remove your this type of gray color, okay, and create the one class. Okay, so for that this time it not need, for the min max not need, I remove it. Okay, it not need. When I apply the self function, then it's not need, I remove it. And further also remove the gray, it's not need. So now it show the one class, okay, and display the result as a blue color. So now I run the code. So now it create the only for the blue color without gray. Okay, only for the one class without gray color. But previous time I create the binary class. One class is show for that gray. There is no water body, or there is no water body, and another class for the water body. So now in this case, if I just open this map, suppose just open the first layer. So now we got this type of imagery. So you can see we can got totally this type of without gray color. We got this type of only for the water pixel. So now I just simply overlay with this map, as well as if you want, you can also edit the other map. Suppose just simply open the dry imagery, then we can easily get it. This type of dry imagery here you can see. Okay, so in the dry season, this type of place there was no water body in the dry season. This type of place there was no water body, but in the rainy season we find out this type of place for the water body. Okay, You can see this type of water body pixel. You can easily get it. So this is the process to make the binary class. Okay, we can easily apply this type of binary class, or if you can simply use the self marks function, and further just simply take the this type of remove the binary class, just keep only for the one single class. Okay, and we represent it as a blue color, which is indicating the wet season water. Okay, so now I will show you the another example for flood mapping. Okay, then you can easily get it how it will work. So in the flood mapping, we are also apply the same process in the Sentinel-1 SAR data. Okay, same process we are just applying. Just set the thresholding value, and then we differentiate for the permanent water and flood water using Sentinel-1 SAR data. Further, we can easily use it to identify for flood damage assessment, how much cropland or how much build up damage for that. We can also calculate this type of things. Suppose just I simply open my previous and show you this one way. Suppose flood. Suppose I just try to open the flood map. Okay, so just I open it. Flood of select. Just I try to open it. Innovation. So let me run the code and check the result first. This is the one kind of flood map for that India boundary. Okay, so let me run the code. So this is the current flood map for the Penny. Yeah. Currently, this type of place is lot of flood happened. Okay, and also some Indian place also this type of place is a lot of flood. And this is the result for 2024 08, meaning 20 August. Okay. So now here you can see we can got this type of things. So basically, this is the code. We can easily find out this type of things. Here you can see. So I also send you the code. You also try to practice for your own study area. Okay. So what is the main themes? So first of all, this is my study area. This is my boundary area. And then before flood and after flood. Okay. Suppose this is my before flood imagery. So here you can see this is the imagery for the before flood. Okay. So just I simply put the time period and we can easily set this before flood. This is the before flood condition. And after flood, we got this type of imagery. So here you can see a lot of water pixel. So basically, this type of black color or dark color indicating the water body. But you can see before flood, there was no. It's totally show this type of color. But when I open the after flood, then we can easily get this type of things. Okay. So basically, this type of color indicating about that water body pixel. Okay. So now further, what can I do? Further, we simply find out the thresholding value for the before flood and after flood. Okay, before flood and after flood, we simply find out the thresholding value. And then we find out the difference flood areas. Okay, so here you can see you can got the flood areas after applying this thresholding value. Okay, so this type of place is the totally flooded. in this for this flood. Okay, and this is the flood status. You can see year of 2000, mainly 20 August to 30 August. So this time period we find out for this study area this type of flood water. Okay. As well as it also estimate the how much area. So we can find out this total area about that this type of water pixel, how much area. We find out that 26,520 hectares area flooded. Okay, and estimate the number of exposed population. It's not update data, but when you apply your own update data, then you also get the more better result. So it's the data for 2015. Okay, as well as if you want, you can also use here the update land use land cover map. Suppose you have this time period 2024 land use land cover map, then we can easily estimate the affected cropland area. Okay, as well as how much urban area also affected, we can also do it. For that we need the update land use land cover data. So for that further class I will try to discuss about that how we can easily create the land use land cover mapping. Then you can easily combine this type of things and also check the flood condition for any study area. And we can got this type of result here, you can see, as well as population density. This is the population density map. Okay, and this population density basically it's created from the data of 2015. Okay, this is the map for population density. This type of white color indicating about the high density of the population, as well as you can see export population. So basically you can see this is the and land cover. This is the not update, and also cropland. Okay, so basically this is the cropland map and affected cropland. So basically you find out this type of green color, it's a cropland. This type of cropland is affected for this flood. Okay, and for the affected urban land is not mass, because you can see this is the urban area. This is the red is more urban area. Okay, and it's a rural place, so that's why it's not mass more urban area or built up area. Okay, it's not mass affected. Okay, so this is the one kind of flood mapping and also flood damage assessment. We can also do it from here. Okay, when you want to just input your update data, then we can easily get that for current situation, what the scenario, what's the how much cropland is the affected. We can easily do it from here. So this is the same concept. It also use for just taking the before flood, after flood, and then use the thresholding value and then check the flood areas. Okay, so this is the one flood method. Okay, so I will show you this code also. You also try to check it. As well as suppose I will show the another process. Suppose flood inundation map. Okay, so in this case, so this suppose I want to show this result for suppose. Okay, so it's not my study area, so I want to just use it. Okay, so this is select study area, and 2022 we find out that lot of flood in the select. Okay, so in this case we also use the same process to do it for flood inundation map in the select study area. So here you can see I will show you the result. For that, just simply create the before flood and after flood condition. Okay, so these things you can also do for the Sentinel 2, but flood mapping is very better to use the Sentinel 1 SAR data, because Sentinel 1 SAR data have the lot of benefit to identify the flood area, because it easily work in the cloud cover region. Suppose in the flood time we find out the lot of cloud in the sky, so that's why it's better to use the your Sentinel 1 or SAR data. Then this type of cloud is not affected our map. Then we also get the more better map when you want to use the Sentinel 1 SAR data. So that's the region when you want to make the flood mapping or flood damage assessment, then try to use the Sentinel 1 SAR data. Okay, but normal, suppose this type of water logging in the city or any specific region, okay, without flood, then try to use here the multispectral satellite imagery such as Landsat or Sentinel. But for the flood condition, when you get the more better result, then you must need to use the SAR data, mainly Sentinel 1 SAR data we need to use. Okay, so here you can see this is the layer about that. I also add the lesion also in here. So here you can see we can get the water body. Okay, so here you can see this is the imagery for the before flood. Okay, so this is the condition about the before flood. We find out this type of map for the before flood condition in 2022. Okay, and further when I just click on the after flood, then we can get, you can see lot of water body pixel increase. Okay, water body pixel is the increase after flood. So this is the condition for the after flood. Okay, So this two layer, so basically this two layer, before filter and after filter, this type of Sentinel-1 imagery have some noise or have some pixel. Okay, so this type of pixel, unnecessary pixel. So basically it's one kind of correction. Just we filter, just remove all of noisy pixel from Sentinel-1 SAR data, and then we can create the before filter and also after filter. Okay, so against the after filter increasing a lot of black. Okay, we find out the dark pixel, so it's indicating the water body. Okay, and further just simply set the thresholding and calculate the flood inundation. Okay, then we can easily get this type of water body is the flood inundation or flooded area, flooded water body area. And then if you want to check about the water body, so this is the permanent water body. Okay, so this type of blue color indicating about the permanent water body pixel, and this type of red color indicating about that your flooded water body. Okay, and further we also calculate the area. Okay, so here you can see we also calculate the area, total area. Okay, so before that I also try to calculate the area in our code, then you can easily use the same process also for this code. Suppose I want to calculate the area. Okay, suppose in this time I want to calculate the area, how much water body we find out in here. So it's very easy, just we can calculate the area in any unit, a square meter or hectare or a square kilometer, we can easily calculate the area. So for calculating this area, we are just use a function. This function called the, I simply write the function in here. Suppose e dot image dot pixel area. So this is the function we have to use to calculate the pixel area. Okay, and when I use this function, then we can got the result in a square meter unit. Okay, this show the result as a square meter. We can easily convert. You can see it show the pixel in the square meter, but further we can easily convert into a square kilometer or hectare or any other unit. We can easily do it. So now I will show you that how we can easily